McGill Robotics Info Session. So thank you all for coming today, for being on time. We're going to try and keep it very brief today because I know you all have a lot of exams and work to be done. It means a lot though that you came out. Thank you. McGill Robotics is a lot of dedication, and so being here on the eve of exams is a good sign that you have what it takes to be on McGill Robotics. Today what we're going to talk about is what McGill Robotics is all about, explain to you a little bit about our robots, what we're doing, and what it's like to be a part of our team. We're going to talk to you about why you should join, why this is such a great experience that we think that you would enjoy and would get a lot out of. And then we're going to talk about how you can join, the application process that happens in September every year, and what you can be doing over the summer to prepare for that. So, a little bit about our values as a team is we've got this mantra that we say a lot, and it's about team before machine, and that is pervasive throughout everything we're doing. And because one of the big goals that we have as a team is to train other engineering students and to learn from one another and to gain skills that are really useful for the rest of your life. And so we build robots of a variety of sorts over the course of a year, and the objective of that really is to gain a lot of cool experience and to become a cohesive team, a solid community that you want to be a part of. And so team before machine is something that guides us throughout our design work. We're also the most interdisciplinary design team at McGill. I'm going to talk to you a little bit about that. And we work hard and we learn together. So team before machine is something that I started this year after hearing a speech by a famous designer who was actually one of the lead judges for the Formula SAE competition. And he was talking about how if you want to build a race car, what you have to do is first build a solid team, a core group of engineers and all the other members of the team that work hard together and put in these long days to building a race car. And if you build a solid team first, a race car will follow. But if you focus too much on building this machine that's a beauty, you can let the other things fall behind. And so this is what our guiding value is. We're also the most interdisciplinary design teams, building a bunch of different robots. And so you can see here's 4 CAD models of various vehicles we've been building lately. One is the first one we built as McGill Lunar X Robotics. That's the team that we were 2 years ago, and we've evolved into McGill Robotics and have started building the other vehicles you can see here. So this is an autonomous underwater vehicle that we're currently building right now, and we're going to be competing this summer in San Diego with this vehicle. In the bottom left, you can see the atmospheric descent vehicle that the CANSAT team within McGill Robotics is building. We'll go into that a little bit more detail. And this is a preliminary CAD for the Explorer bot that you can see here on the left. This is a robot that's designed to work at McGill itself and drive around delivering packages, whether it's flowers or beer or anything else you want, to various different people. And so we really try and touch all the different bases, whether it's space, we've got rovers that are built for the moon, whether it's underwater, submarines, or even just McGill classrooms. We're trying to do a lot of different things. Interdisciplinary also means that we rely on people from all sorts of different majors. And so you can see this pie chart shows that we've got all sorts of different engineering majors, and these are just the engineering majors. We also, beyond that, we have lots of people from business, from arts, from physics, from computer science. And one of the great opportunities of being on this team is working with people from all these other disciplines. In school, a lot of the time you're going to have a solid core group of friends that you're working with, but they're going to be in your major, working on your assignments together. And so this is a nice opportunity to get practice working across disciplines, which of course you'll be doing a lot of in the real world. So what are we recruiting for is we're recruiting for people for a bunch of different positions. And within engineering, we've got 3 major divisions, and that's the software, electrical, and mechanical divisions. And so you certainly don't have to be studying one of those engineering majors to participate in those divisions, but we have these, and so you would fall into one of them. And so, for example, you could be studying physics and be in the software division, or you could be studying mechanical and be in the electrical division, but you are a member of one division from the beginning and you stay with them for the course of the year. We also have a business team, and that's sort of broken down into two major categories of finance and media. And so these projects are very expensive, and so we raise a lot of money to finance these projects, and then we account for all this money and we spend it all. And so this process, there's a lot of quantitative thinking involved there. And then there's also media, so whether that's social media, whether that's designing our apparel, whether that's designing posters that hopefully a lot of you saw today that brought you here. This sort of thing kind of sparked the creativity in you, and so we have that. And lastly, we really work hard and we learn together. I'm going to put this bluntly, we work very hard. We were preparing hard today, for example, to present this presentation to you today. At the same time, we're working on testing and building our robots. At the same time, we're studying for exams and finishing our final projects. And so it's certainly not a light walk in the park, but it's so rewarding. You can see there's a couple pictures here of the one on the top is some of my teammates who are doing some last minute fixes on this robot right here. A couple days before the competition at the Kennedy Space Center in Florida. So really working hard and learning together there. And then this is our workshop here, just in the basement below us. This is a bunch of my team members, teammates working on the autonomous underwater vehicle. And so one consequence of spending so many hours together and working so hard together is you pick up a lot of skills just casually. And so if you're working on a mechanical aspect of the robot and someone next to you is working on a software aspect of the robot, when you spend enough time together, you just sort of get to absorb a little bit about what they're doing and picking up key words about what they're doing, and that I find very valuable in terms of just feeling competent as an engineer and understanding how the world works. So I hope that you're here because you like to work hard and that accomplishments really motivate you and you're excited to join our team next year and work throughout the entire year to build something big and something exciting and work with a lot of different people to do that. So now what I'm going to do is I'm going to invite Michael up to give you a little presentation about each of the different vehicles that we built and the accomplishments that we've made.
My name is Mike. I'm currently the mechanical division leader here. This is my second year on the team. Last year I was in the mechanical division working on this robot, specifically this back part here. And then this year I was in charge of the design of the AUV. So I'm going to give you an overview of some of the robots we've built in the past and are currently working on. So I'm going to start with El Gordo, which is the cute name we have for this thing right here. So El Gordo was built for the NASA Lunabotics mining competition, and so it is a lunar rover style vehicle that was designed to mine lunar regolith. So it's really in a simulated lunar environment, and the goal is to dig up as much lunar regolith as possible in a allotted period of time, and additionally navigate across a small obstacle course in order to do that, and then dump it back in a bin. So we've got a couple of pictures here. So you can see up here, you can see here as well. In the front we have an auger mechanism, which was our digging platform. It works like a snow blower and churns up the dirt in front of it, shoots it up into a bucket in the back, which is collected here. And then we have an active suspension system which can raise and lower the vehicle so it's able to drive over dirt, craters, rocks, things like that. And then this whole bucket actually works like a dump truck, and it's able to lift up and back and dump the dirt. And so we would drive lower down with the suspension, dig up dirt with the auger, drive back across the course, back up to a bin, and dump it out of the back. Another picture here from the back. And so that was for last year's competition, which was in Florida and is an American competition. And unfortunately, they changed the rules this year to limit to only American teams. And so we were unable to compete. But we had a blast at the competition, and there's a good chance that it could come back. So We keep this guy around and could potentially be working on more rovers in the future. But I'm going to go through some pictures of the competition because it was an incredible experience, and we're going to go back to a competition again this year, and it's one of these really cool things to look forward to and become part of a team and have it be like a real goal in your year. And so we don't have any pictures of this year's competition because we haven't gone yet, but just an idea of what you're getting yourself into when you join a team like this and get to go to a competition. This is us after the competition was over, posing with the vehicle. This is us at NASA, waiting to get the robot inspected. Working hard in a hotel room where we were staying in Florida, doing some last-minute preparations on the vehicle. This is us in the Luna pits, wearing our suits to protect us from the lunar regolith that we were digging out. Some pictures of us on the beach testing in Florida. We set up a whole course right down on the sand that was sort of simulating the environment we would be digging in. A bit more of the relaxing, grilling side of testing on the beach. Some leisure activities while on the beach in Florida, grilling, dancing, drinking. So anyways, it's a lot of fun. Competition is something to really look forward to, being a part of a team like this. So it's part of being on the team. You get to work really hard, but you also get to make some friends and play hard. Talk a bit about Robo Ventures. So this was a new team we started this year, which we created as an opportunity for people who really wanted to get involved with robotics, but couldn't necessarily commit as much time or didn't necessarily have as much experience and really just wanted to get their hands dirty without committing to a massive year-long project. So here we have some of the team posing with some students, because what Robo Ventures does is it builds smaller, shorter-term robots. So it's less of a time commitment, but it's still a really cool project, but you can complete them in about a month or two. And so this was the first robot we built, which was called the WALL-E-Bot, and what it could do was autonomously navigate around walls in a room. So it had sensors on the side that would allow it to drive sort of like a Roomba vacuum, where it would drive up, it would see a wall, and it would turn and keep driving until it saw another wall. The other robot that Robo Ventures built this year, which ended up being much bigger scale, seen here giving flowers on Valentine's Day. We have it nicely dressed up in a tuxedo. And it's pretty cool. It's got a claw on the front, a video camera on top, which sends a video feed to the operator who is on a computer and navigating it from somewhere else. So it could be used. We're going to continue to work on it this year and maybe deliver some other things. But Robo Ventures in general, it's a really good opportunity if you want to get involved with robotics, but you can't necessarily commit to the big project that we're currently working on, which this year is an AUV. It's a really good opportunity to get started. CanSat, it's called CanSat because it is a satellite in a can. It's not immediately obvious, but it's an atmospheric descent vehicle, which means it is this package of sensors that gets launched with a rocket up to a certain height where it's deployed, and then it falls, and as it falls, it sends data back to the ground, and then it additionally has a payload inside that it needs to protect. So as it falls, it's collecting data, and then it needs to open up some sort of descent system so that it falls slow enough that it can protect the payload. So here you can see in the CAD the kind of wings that come out act to slow the vehicle down, and additionally it needs to be powered on its own, so it also has solar cells on it to power the vehicle. So that's one of our smaller design teams, but is equally as cool, and it's a bit of a different experience working on a very different type of robot. Finally, we have the AUV, which is this year's new big project that we're working on. So an AUV is an autonomous underwater vehicle, which is a small underwater robot that's entirely self-propelled, and it's not not operated by a person. So it's completely programmed to complete a certain number of tasks autonomously in an underwater environment. So it really brings a whole new array of challenges that we never experienced before with the current robots we have. And it's being designed to compete in a competition this summer in San Diego called the AUVSI RoboSub competition. It's an international competition, so they can't kick us out of it. But we're up against some of the best universities around the world that come from all over to compete with us. So it's definitely a big challenge, and we're really thinking long term here with like adding more and more features every year and just really making it better and better every year. So next year is going to be an amazing year for this because it was our first year. We had to start somewhere, and next year we're going to be able to make it even cooler. Here's another view of it. So the way it works is it has 6 thrusters. Go back here. So you have 6 thrusters which control 5 degrees of freedom. So there's one here and one on the other side, so this is the starboard. There's one on the port. There's one here on the bow, one on the stern, and another one in the heave direction on the bow, and another one on the stern. So they work in pairs to translate the vehicle side to side, fore and aft, up and down. And additionally, as they're coupled, they can rotate the vehicle like this and like this. And then these rectangle things are actually cylinders, and they house all the electronics in various pressure vessels, what we call them. So on the top, you can see the large one is the main hull. And that contains a computer, a power distribution board, microcontrollers, sensors, and then externally you have 2 forward-facing cameras here and here, one that you can't see down here which faces downwards, and those send a video feed to our software system that uses computer vision to navigate. Additionally, there are 2 battery pressure vessels on the sides that contain our power. We have a pneumatic system that fires torpedoes, drops markers, and controls 2 grabbing claws along the bottom. And it's all designed to be neutrally buoyant so that we can control our buoyancy actively, so we can go down and up. So we got this cool picture here of us testing recently. We finally got in the pool a week or 2 ago after completing all the mechanical design, and so now we're able to test some hardware, test our software and electrical systems. So that's our current big project right now. It's pretty cool, but there's still a bit of an open invitation. We are a growing team, and previous years we've been smaller, and this year has been our biggest year, but we're really continuing to grow. And what we've tried to set up is a great base for more teams to exist. We've got a lot of momentum and support, and so we currently have these teams where we're building an AUV and some smaller vehicles, but there is potential in the future that we will do other competitions. So just so you're aware, like there is potential for other teams to exist. So that's it for me. Ross is going to come up here and talk about what you're going to learn.
Hey everyone, I'm Rasha. I'm the business team leader. So why you should join Robotics? What is it going to bring to you? All sorts of skills, technical skills, soft skills, and obviously it's going to look good on your CVs. A lot of employers are looking for students that participated to design teams because they were in design teams themselves, or they know everything that it involves in terms of teamwork, in terms of technical skills. So first of all, mechanical engineering. So you're going to learn a lot about manufacturing, what you necessarily don't learn in class. You learn your theory, you learn all your, mechanics class, analytics and stuff, but you don't actually learn how to manufacture properly, how to apply it in a concrete manner. So this year, and last year too, which was really cool in McGill Robotics, that we got to touch on 3D printing, which is a really new technology. And so Symmetrics and Stratasys are our main sponsors for that, and they helped us build this torpedo launcher, the grabber, all these 3D printing, so it was really interesting. We also have laser cutting, which was really cool to build prototypes, to build a lot of different things. It's really precise. It's a new technology as well. And what you also learn is design. It's not just a robot. It's not just the robot doesn't appear like that. It's all a research and a thought process, and you start with like a random idea or general idea of what you want to achieve, and like you have multiple iteration until you get to a better robot, a more defined robot, until the final design. And that's what you really learn in this design teams is you learn the whole thought process behind your work, and that's really cool and useful. Electrical engineering. I'm electrical engineering. I'm a U3 electrical engineering, and we learn a lot of things, a lot of cool things, but it's really a lot of theory, a lot of math, a lot of abstract things. And what's good about joining this team is that you get to apply these things. And so you're going to learn a lot about circuit design. Like in class, you'll learn about your different components, your transistor, your resistor, etc. But really, when you have a concrete project like that, you'll learn how to design your circuit and how to use your component to achieve what you want to achieve. You get to learn about breadboard and soldering, which you're going to use a bit in your degree, but not that much, but it's actually really important. You're going to learn a lot of power engineering, especially with the AUV and with this robot as well. We have a section dedicated to the power distribution in the robot because it's one of the main important components of our electronics. And so we got to design PCBs. Last year we had like a bunch of wire like randomly together, but this year we designed it on a computer, we cutted it, and we sent it to fabrication, and we got like really nice PCBs, looking really professional, that the power team put together. And they weren't necessarily, they were in U1 and U2, and they got to learn all of that and got to learn about transistors and MOSFETs, and whereas you only get to learn that in electronics and you don't even know, like you don't even apply it in a concrete manner. So that was really cool for them. Software engineering. So especially the project that we're currently working on, the EUV, involves a lot of software. It involves computer vision, which is really, really cool. Basically, you have cameras in the front of the robot, and it looks down also, and you get to get images because the task involves to see gates, to follow lines, to detect pulleys and stuff. So you get to get your images and process them through the software and analyze the images and know that you detected the gate, etc. So that was a really, really cool project. But you also learn how to manage a large integrated project, a large integrated software project, Git version control. You'll get to learn C++ because the AUV is coded in C++, about ROS, which is a robotics operating system, and OpenCV, like I said, computer vision. But it's not only technical skills. You learn a lot more, and which are very, very valuable skills when you get to work. Basically, obviously, teamwork. We're like a big team, and we get to work on this together. And as Nick mentioned, our motto is team before machine, and you can't have a successful project without a solid team that works together towards your objective. Communication was really, really key. We got to use this year, thankfully, to Podio, which is a project management software. So we're a lot in the team, and obviously it's not always easy to communicate within the team. So we got this awesome software that makes it way easier. And you get to learn that because when you're going to work in the company and stuff like that, you're going to be in teams, in project teams, and you're going to have to communicate. It also teaches you about time management. As Nick mentioned, it's a big commitment, and obviously you have that, you have school, you have other things, and you really learn how to do things efficiently, how to finish your assignments efficiently, how to study for an exam efficiently, because you also have McGill Robotics in the picture, and that's really useful. You also get to learn about leadership because we have like different sections and divisions, and you get to, if you're motivated and enthusiastic, you get to lead a team. I joined the team this year, and I started as electrical division leader, even though it was my first year, and that was a really, really awesome experience. I got to manage all the different sections and integrate all the different sections in electrical division, and I learned a lot about leadership and how to manage a team. And finally, we're 100 people, and as mentioned, different sections, division, different projects, and so we're basically like a mini company. And that's why we decided to create this year a business team that takes care of all the business side of the team, because as Nick mentioned too, we find funding on our own. Obviously, McGill helps us out, EUS helps us out, MESC and stuff, but we still need to raise a lot of money to fund our project that are pretty expensive, to fund our trip to competition. And so the role of the business team is to provide real value to the sponsors, make sure they have enough exposure and stuff so that they're willing to sponsor us again and again and to fund our project. So these are some of the sponsors that we have, like Bombardier, Cisco, Stratasys, as I mentioned, MDA, which was all sponsors that decided to help us out this year. So thanks to them. Besides sponsorship, we also have marketing team. So the marketing team that makes sure we have enough exposure, our name gets famous, and so that sponsors are more inclined to sponsor us again. So you become master of digital marketing. So all that concerns our presence on social media. We're trying this year to really be present on Instagram, on Facebook, on Twitter. Ensure the branding. As we mentioned earlier, yes, last year we were McGill LunarX, and this year McGill Robotics, and we're trying to have this kind of umbrella organization, and so we rethought the whole branding thing for McGill Robotics, and also build continuity. So the more we talk, we expose like McGill Robotics, the more people are going to talk about us, the more we'll be known next year and years after, and we'll be basically legit design team. So that's the kind of thing marketing does: business cards, events, our Facebook page, whatever. We also have a media team, which takes care of everything that's graphics and videos and stuff like that goes along with marketing. Obviously, why I chose McGill University was a cool video we made where members of the team explained why they decided to choose McGill, and actually McGill shared our videos. That was pretty cool. The logo too is our graphics person that did that. So these are the positions that we have in the business team. So as I said, sponsorship, accounting, obviously all that money that we receive and that we spend, it needs to be tracked. So we have an accounting team that takes care of all that. And as we mentioned earlier, we're a really interdisciplinary team. We have people from actually from des Hôtels, from management, but also one of our accounting guy is a physics major. He just has a really big interest in accounting, so we really welcome everyone. Media, so as I said, graphics and video editing, video director, marketing, webmaster. Actually, having the website is part of the competition. We need to submit a website, so we try really hard to have a really nice website, but not only for competition, obviously for exposure as well. So we have someone that takes care of that, and logistics, someone that takes care of everything, that's booking rooms and making sure all our events are well coordinated and stuff. So yeah, that was me. Thanks.
Hello everyone, my name is Genevieve. I don't have a structure for this, but I'll try to keep it short. In terms of why you should join, McGill Robotics is definitely a network, and that means two things. One, because it's interdisciplinary, you have a lot of students from different grade levels, and they're in different disciplines. And so they've taken courses before, and they know the good professors, and they've done well in their classes, and so they can tell you, if you ask, sort of what to study for the final, how to manage your time, how to study efficiently, and have that be qualitative in order to do well, and also to do well in robotics. Because we have a really good outreach effort, we bring in a lot of professors, and we also, we had a demo where the Canadian Space Agency came. And I know a friend of mine was able to secure an internship because he talked with an individual there. So McGill Robotics is a really good network community, and it's also a really big friend group. And so what that means is, so because McGill Robotics is a really big commitment, you want to enjoy being there. And I think a lot of people are motivated to work harder because they enjoy being in MEDN, which is the robotics lab in the basement. And so when I joined earlier this year, I was first year software student, and I didn't know anybody, especially because I was living off campus. And I think McGill Robotics really did become a second home. I never spent that much time in MEDN, but I always looked forward to the demos that came every 2 weeks. And I think to say that McGill Robotics isn't a friend group is, I don't know, is completely wrong. So it's not just professional. You have a lot of people helping each other out. And then, so building something. So why is it fun to build a robot? Well, you learn a lot, and I'm not particularly in engineering, but I have heard that you learn a lot of theory, and it's vital to implement, especially because that's what you're going to be doing later. So every 2 weeks we have demos, and those demos display kind of what people have been working on, the goals that they had, the goals they reached, maybe the failures they had, but what they learned. And those are opportunities for everyone to learn about what's going on, not particularly in their discipline or division, but still pertaining to the club. That's really important because everybody cares about the success. So that's something we do really well. But you also learn a lot about really relevant technology and companies. So we used ROS, Robot Operating System, which is not something I think a lot of people know about, but is actually really relevant when it comes to robotics. There's CAD. A lot of people just completely not concerned with CAD got to learn about it. The modeling device, then we learn about GitHub, we learn C++, I'm in the software division, so. But I also learned things about mechanical and electrical, which I think I wouldn't have otherwise. And one of the things about us all being a friend group is it allows us to talk to each other and to learn about each other's interests. I think one of the really great things about robotics is that because it's a university design team, it's not inhibited by kind of like corporate imposed deadlines in which even though you want to do something great, you have to make something functional. And I think as Mike said, this year we had to just get a robot on the table for AUB, but next year I guess the sky's the limit. Like we can do a lot with what we have, and I think every year we improve. A great thing about McGill Robotics is even though it's a commitment, it can be a really long-term commitment in which the more you put in, the easier it becomes and the more you learn. And the more fun it is. So I think that's really important. And then I also think something that's really special is, as Nick was saying, team before machine is actually a really valuable sentiment because McGill Robotics really values self-development and how you feel as a person. And I think in terms of like engineering design teams, or especially in our kind of culture where we have to produce something, I think it's really special when you can also think about like about developing yourself and leveraging that with productivity. Next slide. Oh yeah, community. Wait, is this? Community. It's a community. I think that's it. I didn't know what to say.
Yeah, community. Hi everyone, my name is Felix. This year I was the electrical lead, and next year I'm going to be the project manager for the AUV design team. And today I'm going to talk to you about basically how you can join McGill Robotics. How it works is basically at the start of the semester, what we do is collect names of everyone I want to get in the team. We collect your name, email address, what major you're in, and what year you're in. And after that, there's a month in which we just place you in a team, like 5 or 6 people, and you do a little project. We give you the project, you do it, and what we're doing during this month is like seeing how you work in team, how dedicated you are with your team, how much knowledge you have. But it's also to create a team. Like as we said earlier, we really want to build a team, a strong team before the robot. So it's also to have a lot of fun. I'm going to show you here the project that I did when I came in Mega Robotics. The project was to do a musical instrument with an Arduino. So what I did is the musical instrument only plays if you drink beer. And I had like sensors to modulate the sound, and you'll see what it looks like. Oh, wait. Sound.
Check this out first. Check. Use the volume up.
Yeah, that's about it. It's just have fun, like I said. After this month of like trying to know you and stuff, there's another application form in which you explain a bit more about you, what experience you've had. This is really the place where you can impress us. This year there was one that actually wrote that he was an origami master. That was really impressive, so he's on the team this year. We also try to focus on U1 and U2 since we're trying to get young people that grow with the team. That doesn't mean that we're not accepting U3 and U4, but we're really focusing on them because like, we want to share our knowledge as being older to them so that like, the knowledge can pass on from people to people, from year to year. One last thing I'd like to say is that we really encourage girls to be part of the team. Yeah, you're on last, but we don't have a lot of girls in engineering, but I think having girls in our team is a really good thing because they bring new ideas and it changes the dynamic of the group and the team. And this is really valuable, I think. So that's it.
Good morning, everyone. My name is Jean-Sébastien. I'm in charge of the software division. So today I'll talk to you about how you can prepare the summer, in order to join the team next year. So the idea here, there's a to-do, but focus on the actual picture. The idea is you build something this summer, really. You've got plenty of time, maybe you're working, maybe you're doing some summer courses. It's the ideal time to learn new stuff, to build something, and then come back in September and say, hey, look at what I've built. I've been doing this summer. I've learned a lot of stuff, right? And we'll be impressed, and we'll hire you. So this is what the first thing you should do. Another thing you should do is learn about Mega Robotics. You should go first on our website, check what we've done so far. Go on Facebook, Instagram. I don't have Instagram, but that's all right. Just go on Facebook. You probably have Facebook anyway. I don't have Twitter either, but like go on Facebook. Read about the competition rules. As Mike explained and the other people explained before, we're building an autonomous underwater vehicle. So it would be good if you can go and read the rules. Sorry. Go and read the rules. Make sure you, or if you don't want to join the RoboSat team, there's also CANSAT. That we are an umbrella organization. There are multiple design teams in it. So you should go and read the rules about the specific competition you want to participate to. Read about also the other competitors. There are different teams. There are multiple teams that we are going to compete with. And it's important, we've done that kind of research at the beginning of the year where we were reading about the other competitors because sometimes they've been there for a couple of years and they have nice ideas and once in a while taking one idea of another team can help us out. So if you come with something that would really improve the robot, that would be good. So again, a list of what to do, volunteer in your community. We're looking for candidates that are highly motivated and highly competent. So volunteer in your community, give time, learn about the robotic culture. You should go on IEEE Spectrum. It's an awesome website, seriously. every Friday they post videos about technology stuff in general, robotic stuff in general. It's very interesting. They also have a paper magazine if you want to pay. It's not expensive. It's like I think it's like $5 per month, and you'll receive it. And then they are going to publish a lot of awesome things that you can read about related to technologies and robotics. Also go on YouTube. Just go on YouTube, type robots, enter, and take a look at the videos. There are lots of universities that want to showcase their projects, and you'll see that there's a lot of interesting stuff related to robotics. And then again, build something. Start your summer. You have plenty of time. Go buy an Arduino. It's really cheap if you want to do something related to microcontrollers. The programming language is easy to learn. That was more related to electrical and software. So then, if you wanna join a mechanical team, you can design something in a CAD software, because we use that to build that robot. We're using that CAD software to build the underwater vehicle. So, and more specifically, we're using the Autodesk Inventor. So just go on the internet, download it, start playing with it, design something, and then work with tools. It's important that because we're building everything, most of our robot has been built in NVIDIA, and we play with tools. So if you come and you already know how to manipulate these tools, it's a plus. It's going to show that you know what you're doing, and it's going to be a plus for the overall team. If you want to join the software, if you're more software engineering or computer engineering person, again, build something with the tool that we use. You should learn C++. If you want to work with computer vision, learn OpenCV. We use ROS to manage the inter-process communication between the different processes. We also use an Arduino for the low-level system. We used that on last year's robot. We still use that on the submarine. I don't know, I'm pretty confident you guys have heard of GitHub. If not, go create an account. It's a nice website where you can push your code. It does version control. You can contribute to various projects. You can, if you're a big team, for example, like us, it's a nice software. It's a nice server where we push our code and merges all the changes. So for multiple people working on different parts of the project, you push there, all the code is combined together, and everyone's happy. Ubuntu, lots of companies use Linux-based systems, so we do. This robot was also on Ubuntu 12.04. This year we're still using the same version of Ubuntu. So these things will be good if you can learn these during the summer and build something. So software engineering. Also, if you want to, I would highly recommend these books. Effective C++. It's a nice book that will teach you all the best coding practices in the C++ language. Refactoring by Martin Fowler. This book is more oriented toward Java, but the ideas that he talks in it, that he's teaching in this book, are portable to any language. It's how you structure your code. He's gonna teach you some design patterns that are used in the industry, and that we also use. And speaking of design patterns, I would also recommend Design Patterns by the Gang of Four. You'll see all the classic design patterns that were invented in the 90s that we still use today in the industry. Also, iRobot by Isaac Asimov, but because it's a nice book, and there's multiple robots in it, so it's interesting. So if you're an electrical engineer, for example, again, build something. I think you guys build something, Okay, so solder stuff, build circuits. It's nice, we see that in the classes. Okay, put a resistance and put them in parallel. Try to measure the overall resistance and stuff like that. So build circuits. It's different on paper than in real life. And when you do that transition, it's interesting to see what's the final result. So sensors also. Use an Arduino, buy a temperature sensor, find yourself a small project. Like Felix Showcase is an awesome project where you needed to drink beer in order to play some music. That's awesome. And it's really cheap. Like the Arduino is like $35, so you should really invest in some equipment like that where you can do something during the summer. breakboards. Also, we use the KiCad PCB design. You could also download that on the internet. So if you want to design circuits, for example, that's going to be very useful. It's the same principle as a CAD, but for circuit instead of being a 3D model. So summary, join our community. McGill Robotics is hard work. We spend a decent amount of hours per week. We really have a lot of fun doing this. So when you make the commitment to join the team, you commit yourself to spending a considerable amount of time per week. But remember, that's going to be awesome. You're going to learn a lot of stuff. And all that knowledge is portable to your future job. And it's going to motivate you to perform in school because you'll see like, oh, well, yeah, I've done that in class like 2 years ago, and I can actually apply that in the real world, right? So that's going to be nice, and you'll enjoy that. It's going to make the connection between theory and practice. Prepare to apply enthusiasm, drive, motivation, and creativity. And again, build something. Like, build something. Stay connected on social media. I told you, I don't have Twitter, but still I'm on Facebook. I like the page, I shared it. You should log now on Facebook and like our page, seriously. We post a lot of stuff, we post the progress of the robot. Whenever we do testings, pictures and stuff like that, we post that on the social medias. So stay connected. Again, that robot was called El Dordo. Now it's unknown. We don't have a name for our current robot, so there's gonna be a contest. There's gonna be a contest, and people will be suggesting names, and we will take a name, and the winner will win a $40 card to Chief on Call. That's amazing, yeah? Who doesn't like food? No one. So you definitely wanna send a name, and you get a chance to win that card. Isn't that great? That's awesome. Okay, so stay connected. Again, Facebook, Instagram, Twitter, LinkedIn also. Go on our website. Send us an email, McGill Robotics Team, Gmail. Does anyone in the group has any question regarding what I said or what someone before me has said? Questions, comments? Yes?
So you said the same application process?
It's going to be the same application process. We want motivated people. We want dedicated people. So do something during the summer, build something, get involved in projects, and come in September.
Same application process, but you apply to it. You say what you want to do for the team.
Exactly. That's a pleasure. Any other questions?
So
Yes.
you're saying that the application actually kicks off after the summer,
We start the application process in September. We do our first one where everyone comes, you join a specific branch, and you work on a project. After a month, you do a second application, and then you have got the experience. On the first application, there's no commitment. You know, you come, you work on the project. We want people to be present, of course, but there's no commitment for the full year. So you say, I'm going to be working on a team for a month, and then after that, if I don't like this, then I can drop out. That's all right. But after that, after the end of September, on the second application, when you decide to join the team for real, then it's a commitment of a year. It's a year-long commitment, and we expect everyone to come every week and work with us. But again, a lot of fun. Yes?
Does the business team by chance get involved in the design and manufacturing of the robot? Or is only the business side?
Yeah, if they want. I mean, like, you can do both, of course. You're not necessarily on one or the other. If you want to do, like, I mean, I've done a lot of the media, but I'm mechanical. I did mechanical design, unfortunately. It's just more work. Otherwise, much work.
Yes.
Could it be specific with the time schedule, like the first application start at the beginning of September and the second application start at the end of September? Or you ask us to build something, what is the due date for you evaluating all those things we build?
Okay, so the way it's going to work is that for what I was talking was more during the summer, what you should be doing during the summer, what technologies you should learn, what projects you should get involved in. And then in September is when you come with these projects. At the beginning of September, you do a first application, and you say, I've worked on that project all summer long because I wanted to join the team. Look at my project, and we're going to be impressed. And then we'll take you and put you in a team. You'll start working on a mini project with other people. I'm going to be working with you guys on these projects. And then at the end of September, we do a second application where you decide, okay, with the knowledge base that I acquired during that month, I want to join the software team, for example. And then you do this application to the software team, and we'll send you an email to tell you that you've been accepted in the software team, and then the project starts, and then we start working together on the actual robot.
Yeah, thank you. So let's see, before the beginning of September, we have to finish something we built by our own. And during that period, we have some guidance, like who can form a team, and what kind of things you prefer us to build.
So in terms of guidance, I would suggest to work on something that I've mentioned in the presentation. If you want to join the electrical division, for example, you might want to work on Arduino, on sensors, building circuits. If you're interested into joining the software division, try to learn C++. If you're interested in computer vision, we've mentioned OpenCV. If you want to join the mechanical division, there's CAD softwares on the internet. You can start designing something. Like work on something that you want to work on, that you're passionate about, and then build something interesting, and then showcase it to us at the end of the summer. Do something that you like.
Okay, I have another concern.
Yes.
Sorry for this.
No, that's perfect. That's good.
I mean, have a certain product like can play around on the ground is of course cool, but can we focus some type of things like the simulator, some certain algorithms, some certain software, can we make it part of the project? I mean, maybe there's no specific robot we can put on the table. Like we can do some simulations through the software, like AutoCAD or MATLAB, something like that. Having that, we can put it those.
Yeah, sure, definitely.
Okay.
Definitely. Any other questions? No? No more? Okay.
If you're interested in getting on the mailing list, we'll let you know about further info sessions, things starting off at the end of the summer, beginning next year. I have a spreadsheet up here. You can put your name, year, major, and email. Thank you.